Okay, of course, you're expected to know that the magnetic field produced by a straight current carrying wire is like this, concentric circles, and the field strength gets weaker as you go further away. So let's look at option C. In option C, let's say this is the wire. In option C, we are orienting the coil this way. Alright, so this is the wire, and this is the coil, and we are orienting it this way in option C. So in our cross-sectional view, this coil is going to look like this, right? It's just it look like just a line. So what is the amount of magnetic flux captured by the coil when it's oriented like this? 0, right? Because the effective area that you are presenting to the magnetic field is 0. You are not capturing any flux at all. So of course there's not going to be any induced EMF. Okay, option D. So this is the wire. In option D, we are going to orientate the coil this way. So this is the coil. We are orienting it this way. So in this case, in our cross-sectional view, this coil is going to present itself like this. So again, the area that's facing the magnetic field is 0, right? Some students are very sharp. They'll say that what if the coil is really big? So now I'm drawing the top view. So I'm viewing the wire from the top. So this is the wire. This is the wire, and we're viewing like this from the top. So this is the magnetic field. So if I'm orienting the coil this way, then the coil is going to be like this, right? And let's say the coil is really big, this big. So now you say, that it is capturing some flux, right? You see the flux entering, maybe not perpendicular, but at least there's a perpendicular component. But if you think about it, if you have flux going in this way, then you have flux going out the other way, and everything is symmetrical, right? So the net flux captured in this scenario is still going to be 0. Okay, so in the first case, when we were talking about this one, there was absolutely no flux captured, but when we are talking in this scenario, the net flux captured is still 0, because whatever amount that enters also leaves. Okay, in option B, we are going to orientate the coil this way. So obviously this time around you are going to capture some flux, because this is the area that you present to the magnetic field. So you are going to capture flux here, and because this is an alternating current, you are going to have varying flux, and therefore you are going to get induced EMF. But if you are getting induced EMF here, then you get even more induced EMF if you move the coil nearer, right? Because the variation in the amount of flux you are going to capture is now going to be larger. Okay?